Section number 13 is entitled Solving Linear Equations. First of all, an equation is something that has an equal sign. This is an equation. A linear equation is where the power of x, that is the power of the variable, whether it's x or y or z, is 1. It's not 3. And if there is no exponent, it's understood to be 1. That there is an linear equation. Now we're going to talk about how to solve some linear equations. The number that goes in that box is 3. That is, the box represents the number 3. The box equals 3. But if instead of box we wrote x, x just represents a number to be figured out. Just like the box represents a number to be figured out. Instead of one number goes in the box, we could have asked, what does the box equal? The box equals the number 3. Well, so does x. That must be 3. X must be 3. 3 plus 2 is 5 after all. Think of x as a box. Think of the unknown term as a box. The unknown term is x. Because I know what 2 is, it's 2, and I know what 5 is, it's 5. Figure out what the unknown term is. Okay. Most teachers would prefer for you not to think, and they would say, oh, you take away 2 from both sides, 2 minus 2 is 0, so x plus 2 minus 2, that is x plus 0, is just x. And 5 minus 2 is 3, so x is 3. But that doesn't really involve understanding what the problem is. I know there's a lot of students who they may not know what plus 7 is 100. They may not know that. Fine, they don't know it. So their teacher would say, well, you take away 7 from both sides, and you get x is equal to 93. Or possibly, they solved this problem, and they get x is equal to 93. And then you say to them, what number plus 7 is 100? And they'll say, I don't know. Well, that's a big problem. It's one thing to be able to solve this problem. We solved it. It's another thing to know what you're solving. This problem on top is saying what number, which we're calling x, and we figured out what x is. This top problem is asking, what number plus 7 is 100? Well, that answer is 93. And what goes here? So when I add 7, I'll get 0, 0, 1. Well, to get 0, I better put a 3 here. 3 plus 7, that's 10. Carry over the 1, bring down the 0. Now I have 1, but I want 10. I better put 9. That's another way to do that problem. What number plus 7 is 100? 93. What number plus 2 gives you 5? 3. That's why x should be 3. So, once you figure out the answer, it's good if you understand what that answer represents. And the last problem is that number that when you add 7 to it, it really does give you 100. trouble, to say the least. When my teacher in 9th grade algebra said, oh, to solve this problem, you take away 1 from both sides, that's 0, x plus 0 is x, 2 minus 1 is 1. Not that the teacher was wrong, but the bottom line is, you're making this a harder problem. If it's a 4th grade problem, don't teach it as a 9th grade problem. We don't think of it as a 9th grade problem. We all know that 1 plus 1 is 2. X should be 1. 1 plus 1 is 2. Everyone knows from before algebra that 1 goes there. Well, why when you have algebra and somebody asks you this, you just don't say x is 1 is beyond me. And I remember, I think it was in 4th grade, we used to be given these box equations, and we said 1. We never took away 1 from both sides to figure out that 1 here. Okay, you know what to add 1 to get 2. 1 plus 1 is 2. That number, x, must be 1. Okay, think about what the problem is asking. I have a lot of students who actually get x plus 1 equals 2 wrong. It's because they're not reading the problem. What plus 1 equals 2? They know it's 5. If I ask you this problem, what number plus 4 is 18? 14 plus 4 is 18. There's a couple of ways of figuring that out. This must be 4, because 4 plus 4 does give me 8. And then I've got to put a 1 here to carry down, to bring down a 1 to get 18. 14 plus 4 is 18. Another way of doing it is you're at some number and you're adding 4. 1, 2, 3, 4. And you're ending up at 18. Well, 17, 16, 15, 14. That unknown number is 14. We're calling the unknown number. Maybe I should say unknown term. We're calling 2x. That whole circle is the unknown. It's 14. So 2 times x is 14. Now, we're better at multiplication. There's 2 ways to proceed from here. You can do division by 2. And I definitely support that you know what 2 over 2 is. It's 1. Times x is just x. 1x is x. Now, here is where I don't get why you would divide by 2. Because now, you're going to have to know that division problem. Or, to the left, you'd have to know your 2 times table. 2 times what is 14? 2 times what is 14? And 14 divided by 2. You probably have a better chance of knowing that 2 times 7 is 14 than to know what 14 divided by 2 is. To be honest, when somebody asks me what 14 divided by 2 is, I ask myself, I don't know what 14 divided by 2 is. 99% of the time, I don't know what 14 divided by 2 is. Right now I do because we just worked on it. But if somebody asked me what 14 divided by 2 is, I would ask myself, 2 times what gives me 14, and I would say 7. But if they asked me what 14 divided by 2 is, I would say 7. But I didn't do the division, because I'm not good at division. I never learned division. I never memorized division of numbers. I memorized multiplication of numbers. So, in my opinion, you should ask yourself, 2 times what is 14? Answer 7. Sometimes it won't be on the 2 times table. We'll cover problems like that in a little while. But whenever you can do it as multiplication, go for it. You're much better at multiplication than you are at division. Somebody asked me 7 minus y is 2. Well, you have 7, and now you're at 2. How many? 7, 6, 5, 4, 3, 2. What did you have to take away? 1, 2, 3, 4, 5. That's the answer. 5. This number is 5. Of course it is. 7 take away 5 is 2. You should just know that. 7 take away 5 is 2. Now, what if somebody asked, they said 3 take away x is negative 2. And you're like, oh my, subtracting and I get negative numbers, I don't like this. Fine. You don't have to like it. You don't, because you can rewrite it. If 3 minus x is negative 2, well, if I read it backwards, x minus 3, then I have the wrong sign. It's not negative 2, but it's positive 2. Oh, I know that. 5 minus 3 is 2. 5 minus 3 is 2. Therefore, x is the number 5, and that problem is finished. X is 5. 3 take away 5 is negative 2. And to convince yourself of that, see how much you have to take away to get to negative 2. You're at 3 and you take away 1, 2, 3, 4, 5. And what do you know? You get negative 2. That's what x is. X is not negative 5. X is a number that came after the minus sign. It's 5. If it was 3 minus a negative 5, or 3 minus x, then that's what x would be. But it wasn't that. It was 3 minus 5, or positive 5. If you read a subtraction backwards, then you have to change the sign of the answer. Somebody asked you negative 2 plus y equals 11. Some more thinking. You should know, for example, that from negative 2 to 0 is 2. For the record, from negative 5 to 0 is 5. From negative 8 to 0 is 8. From negative 7 1/4 to 0 is 7 1/4. And from 0 to 3 is 3. And from 0 to 4.31 is 4.31. And from 3 to 11 is 11. So now, you're at negative 2, and you want to end up at 11. Now you can count. Negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Excuse me. 11 should have been down. You can count those and you will get 13. And you should say, I'm done now, x should be 13. But a quicker way of doing it is to play the game with 0. From negative 2 to 0 is 2, and from 2 to 11 is 11. I meant to say from 0 to 11 is 11, and 2 plus 11 is 13. Negative 3 plus some number gives me 8. From negative 3, how much do you have to add to get to 8? Well, say hello to 0. You just added 3 to get to 0, and you added 8 more. You added 11. 3 plus 8 is 11. You add 11. Okay, that you see. You actually see that. I mean, fine, if you add 3 to both sides, this is 0, plus x is x, equals 11, x is 11. A lot of you don't even realize that it's 3 plus x. You say, oh, the 3's cancel, and you just get x. Now, to say the 3's cancel trouble me, because one can argue that this cancels. 13 over 13 cancels. And 13 minus 13 cancels. Here it cancels to 1. Here it cancels to 0. Now, if it always canceled to 1 or 98 or whatever special number things cancel to, that would be okay. When you say cancel, I would know you mean that number. But when you say cancel, and sometimes it's 1 and sometimes it's 0, well then, I don't know what you mean. I don't know what you mean. Have to be careful. Suppose you're asked to do this. 6 minus some number is 11. And you go, what? That makes no sense. I know that 6 plus 5 is 11. What is this 6 minus? Well, you need to understand that the 5 is understood to be positive 5. Because there was no sign. Not because of the big plus sign in between. So you have 6 plus a negative 5. Even though you have a big plus in the middle, that's still a negative number. If there's no sign, it's positive. Well, there's a rule that says that you can change both of those numbers. Both of those signs. Regardless of what they are. One's negative, one's positive, they're both negative. Doesn't matter. You can change both of them. Their addition becomes minus, and the positive 5 becomes negative 5. You get the same answer. That's what x is. For the record, that's not 6 minus 5. It's 6 plus 5, which is 11. This here is not 6 minus 5. It's 6 plus 5, which really does equal 11. So 6 minus what number equals 11? Well, 6 is 6, minus is that, negative 5 is x, equals is equals, 11 is 11. X is negative 5. Okay, sometimes you shouldn't think the way they are. Somebody asks you 10 minus what gives you 15. You should say, how about 18? You should say, come on, I know that 10 plus 8 is 18. What is this 10 minus? Well, change both of those. The sign that you don't see here is positive 8. So this is 10 minus a negative 8, which is 18. Oh, x is negative 8. 10 minus x equals 18. X is negative 8. 2 minus x is 5. You say, and maybe you're going to start catching on. It's 2 plus 3, which I'll write that way. That's x, because 2 minus a negative 3, well, it's not 2 minus 3, so it's 2 plus 3. And of course, 2 plus 3 is 5. X is negative 3. X is negative 3. Always think about it. Stop doing math with your eyes closed. It doesn't work. Most teachers in elementary, junior high, and high school, they teach math purely mechanically. Right? You do the steps, you do that, you'll get passing grades, and you'll move on. They won't tell you what you'll learn. You won't learn much. Somebody asks you what this is. And when you're a little kid, sometimes people ask, they challenge your times table ability. They'll probably say, well, what's 3 times 8, or what's 9 times 2? But they could say 3 times what is 24. And you should just say 8. 3 times 8 is 24. It is x is 8. They'll say, all right, you see, top 7 times what is 21? And you should say, oh, that number that you called what is 3. 7 times 3 is 21. Now, you should know this pattern. If 3 times 4 is 12, well then 12 divided by 3 is 4. So the record is 3 times 4 is 12. Well then 12 divided by 4 is 3. If A times B equals C. In particular, C times B, C divided by A is B. That is, C over A is B. If 3 times X is 11. 11 divided by 3 gives you X. And our problem is done. 11 over 3 is X. Somebody tells you 7X is equal to 11. Well, you don't know, it's not 7 times 1 or 7 times 2. It's not an integer. So then do this game. 11 divided by 7. 11 divided by 7. That's it. Know this pattern. If 9 times X is equal to 6, well then you should say 6 divided by 9 equals X. But this can be reduced. 3 does go into both of those numbers 2 and 3 times. So X equals 2 over 3. The other answers, by design, they weren't able to be reduced. If you can reduce it, go for it. And now, there's another pattern that you should see or know as an algebra student. Let's take the number 36. 36, we'll do it a few times. Do it 6 times, I hope. You can give me 2 numbers, or think of 2 numbers that multiply out to 36. Any 2 numbers. 2 and 18. 3 and 12. 4 and 9. 6 and 6. 9 and 4. 12 and 3. All of these divisions are correct. 36 divided by 2 is 18. You know what? 36 divided by 18 is 2. 36 divided by 3 is 12. I know it. Just 3 times 12 is 36. But you know what? Oh my. If I switch those numbers, it's another equality. If I switch the 4 and the 9, like I did here, I get equality. You can switch those. Because 4 times 9 is 36. And you know what? 9 times 4 is also 36. Any 2 numbers that multiply out to 36 can go there. But if these 2 numbers multiply out to 36, then you have every right to 36 on the bottom. Like 12 times 4 is 48. 12 times 4 is 48. And 48 goes up there. That is 48 divided by 12 is 4. But like I just said, 12 times 4 is 48. 12 times 4, or 4 times 12. That's 48. You can switch those 2 numbers. You can switch those 2 numbers. if you just want to remember it as a boring, dry roll, fine. But you can switch the denominator with the number on the other side. So if somebody says 9 divided by x is 4, for most algebra students, given the way they were taught this, how to solve this type of problem, this is a hard problem for them. It's ridiculous for this to be taught hard. Switch to 2 and you're done. 9 over 4 is x. Next problem, I'm out of here. I'm done with this problem. But first make sure that you can't reduce that. Give one moment. If you were given 14 over x is 21, you could interchange them. 14 over 21 is x. You need to realize that both of those numbers, 14 and 21, they lie on the 7 times table. That is, 7 goes in here 2 times, 7 goes in there 3 times. That is x is 2/3. You have 26 divided by x is 4. Well then 26 divided by 4 is x. That is, I just interchange those. Boom! I have what x equals already. Oh, but both of these numbers are even. 2 goes into both of them. And 13 over 2 cannot be reduced, so x is 13 over 2. You should definitely know this pattern. You should know that you can interchange those two. You definitely want to interchange it here, because then when you bring the x up there, you have x in the numerator. You don't want to solve with x in the denominator. Okay. Now, suppose you have this type of problem. This type of problem is just multiplication problem. It's just multiplication. What's 3 times 7? 21. X is 21. So this product is equal to the numerator. X over 4 is 5. The problem is done. 4 times 5 is 20, and that's what x is equal to. X is 20. We have x over 4 is equal to -7. This product equals the numerator, which is x. That is, that product is equal to x. Done. We have x over -2 is -3. This product, which is 6, equals x. 1, 2, 3. All right, let's do some more. Suppose you had this problem. 2x plus 1 over 3 is 11. Well, what's the numerator? Oh, that's easy. It's 3 times 11. 3 times 11 equals the numerator. Whether the numerator is hard looking or easy looking. Whether the bottom is hard looking or easy looking. You have 2x plus 1, the numerator, is 3 times 11, which is 33. Some number plus 1 is 32. Oh, I know it's 33, excuse me. Some number plus 1 is 33. That number must be 32. 2x must be 32. 2 times what is 32? 16. And if you didn't know that, then you'd have to do 2 into 32. 2 into 3 goes 1 time with 1 left over. And 2 into 12 is 6. So yes, the answer is 16. And you can check it easy enough. 2 times 16 is 32. Plus 1 more is 33. 33 divided by 3, yep, that's 11. 3 goes into 33 11 times. 3 into 33. 3 into 3 go 1 evenly. 3 goes into 3 1 evenly. 11. If you were given this problem, I would interchange this bottom and that top. Why? Because I know what 4 over 2 is. It's 2. This left side is just 2. So number, take away 6, leaves me with 2. 8. 8 take away 6 equals 2. This must be 8. 2 is equal to 8 take away 6. So 2x is 8. 2 times some number is 8. Oh, I know that number. That number is 4. 2 times 4 is 8. Now, if you have, say, 2/3 times 5, well, this really means 2/3 times 5 over 1. So you multiply it to 2 times 5, and 3 times 1 is just 3. Well, how do you go from here straight to here? You just multiply the 2 by the 5. The bottom stays the same. You have 2 over 7 times 8 times 8. 2 times 8 is 16 over the 7. In particular, you have 2 over 7 times x, which you would probably just see this way. This means 2x over 7. And we're going to solve problems where we're going to have to use that fact. Suppose you were told that 2/3 x is equal to 5. If that was a problem, say, in my book, when I would write that problem down, I would write it down that way from the beginning. Now, you can do this problem in one step, but we're going to do it in 2 steps. 3 times 5 is 2x. That is, 2x is 15. That's step 1. Step 2, 15 divided by 2 is x. Actually, step 1.5 was I asked myself, 2 times what is 15? And I'm like, I don't know that answer. 2 times nothing, 2 times no integer is an odd number. The 2 times table only have even numbers on it. So, if you were asked to do 2x over 3 is equal to 5 over 7, well then the denominator times the other side is equal to the numerator. That is, 2x is 3 times 5 over 7. That is, it's 15 over 7. So this number divided by 2 is x. 15 over 7 divided by 2 is x. Now, you learned in arithmetic how to divide fractions by fractions. That is, in division. If one of these two numbers or both of those numbers are fractions, the rule is you keep the top number the same, you change division to multiplication, and that bottom number, which is understood to be 2 over 1, you flip over. That is, instead of dividing by 2, you can multiply by 1/2. 15 times 1 is 15. 7 times 2 is 14. So first I verified I couldn't reduce. say x is 15 over 14. So if somebody asks you 2/3 times what number gives you 5 over 7, if they ask you this in the next 10 seconds, you should say, oh, I know that answer, 15 over 14. 2/3 times 15 over 14. Well, 2 goes into both of these numbers, one from the top, one from the bottom. 3 goes into both of these numbers, one from the bottom, one from the top. 1 time, 5 times. 1 times 5 is 5. 1 times 7 is 7. And what do you know? 2/3 times this very special number did give me 5 over 7. 2/3 times 15 over 14 gives me 5 over 7. It's one level of understanding how to solve this problem. 3x is equal to 7. A lot of students would say, regardless of how they got it, they would say x equals 7 over 3. Then I would ask these same students, 3 times what equals 7? And they'll go nothing. And the argument would be 3 times 1 is 3, 3 times 2 is 6, just under 7, but 3 times 3 is more than 7. So therefore 3 times nothing gives you 7. Well, then they have no understanding what they solve. They're solving for that number. 3 times this number should give you 7. And whether you're right or wrong, if you claim that's what x is, what you're saying is that 3 times that number is 7. And it is, because the 3's cancel out, and yes, you get 7. 3 times this number really, really gives you 7. Okay, let's try some more. And look at some word problems. Whenever one says a number means n for number. You want to use x, you use x. You can use the Greek alphabet alpha, the Greek letter alpha or beta. You can use whatever letter you choose. You can use lambda, doesn't matter. But we'll call it n for number. Now, if somebody said to solve this, 3 less than a number is, say, 5. Well, instead of a number, you should say n, and instead of is, you say equals. 3 less than n equals 5. Well, what's 3 less than n? Here is n, and I made it 3 less. And that gives me 5. And if I ask you, what's 3 less than 10? You probably all would say it's 7. But it's not 3 minus 10 that equals 7. 17 minus 10 is 7. But you know what? 10 minus 3 is 7. You have to kind of read it backwards. The instruction is a number, 3 less than n is a number. 3 less than a number is 5. Find the number. So I wrote it down as an equation. 3 less than n is 5. The n is 8. 8 minus 3 is 5. I found the number. 3 less than 8. If I have $8 and you have 3 less than what I have, you have 3 less than 8. Well, you have less than me. You have $5. How about 4 more than a number is 11? Well, is means equal, 11 means 11. This here means n. 4 more than n. Well, here's n, and I made it 4 more. So, some number plus 4 is 11. 7 plus 4 is 11. 7 plus 4 is 11. So the number is 7. 4 more than a number is 11. Find a number. That's the whole problem. 4 more than a number is 11. Find a number. The number is 7. A number plus 8. A number plus 8 is 10. Find a number. A number is n. N plus 8 is 10. 2 plus 8 is 10. N is 2. Okay. Here's another type of problem that I want you to know how to do. If you do it, if you think of it the way that I'm showing you, it would really eat through the problem. Most people are taught to distribute, and it really makes the problem hard. 7 times what's in the brackets is 35. Then what's in the brackets is 5. I don't care what you see in the brackets. Whatever you see, it equals 5. If you see, say, 2x plus 1, it's 5. This must be 5. 7 times 5 is 35. 2x plus 1 must be 5. Some number plus 1 is 5. This is 4. This is 4. 4 plus 1 is 5. So 2x must be 4. 2 times some number is 4. This is 2. 2 times 2 is 4. X is 2. Your teachers tell you have to show all your work. I did. Most of the work, I mean, yeah, you don't, in adding 23 and 47, let's say 22, you don't have to show why 2 plus 7 was 9. There's some things your teacher allows you to assume. In multiplication, you're allowed to write down 14. You don't have to show why 7 times 2 is 14. Well, I don't have to show why this is 5. I mean, it's common knowledge. 7 times 5 is 35. So this must be 5. I wrote it down. The fact that 4 plus 1 is 5. That's common knowledge. We're supposed to know that. This is 4. I wrote it down. You're supposed to know 2 times 2 is 4. I wrote that down. X must be 2. I wrote down every step that I did. I wrote down my complete thought process. I didn't skip one step. There's not one thing I skipped there. Six times this is 60. Oops, that's 10. 6 times 10 is 60. So you don't even have to write that down. That was just for between you and I. So we know that 3x plus 4 is 10. Because 6 times what's in the brackets is 60. What's in the brackets is 10. This number plus 4 is 10. That number is 6. 6 plus 4 is 10. That is 3x, 6. 3 times this number is 6. This number is 2. X is 2. Okay, let's try one more, and that will actually finish the section. Okay, let's make that plus. 5 times this is 20. And this must be 4. Some number plus 1 is 4. 3 plus 1 is 4. So 3x must be 3. And if 3 times a number is 3, then the number, which we're calling x, is 1. And we could check it out pretty easily. 3 times, okay, sorry. 3 times 1 is 3, plus 1 is 4. What's in the bracket is 4. And 5 times 4, yep, it equals 20. It equals 20. Now, I guess I lied. We'll just do one more problem. Suppose you have this. Say we got 23. Now, you should know what to multiply 5 by to get 23, because the answer is 23 over 5. But we don't want fractions. So in this case, I would distribute. I would get 10x plus 5 is equal to 23. So that number should be 18. Because 18 plus 5 is 23. If you didn't know what number goes there to get 23, well, 8 plus 5 gives you 13, which ends in a 3. And the one that we carried over plus another one, that gives us 2, 23. So the unknown number is 18. 10x must be 18. 18 divided by 10 is x. 18 divided by 10 is x. I divide the top by 2, I divide the bottom by 2. I can't reduce any more. X is 9 over 5. That is 5 times 2 times x, which is 9 over 5, plus 1. This will give you 23. Let us just check that, and that will be it. Try that again. We will use the distributive law, and we'll be done. If only I could erase this. There we go. 5 times 2 times 9 over 5 plus 1. Well, 5 times the first term. 5 times 2 times 9 over 5. Well, 5 in the bottom goes into 5 in the top evenly one time. 2 times 9 is 18. Because 5 goes into the bottom one time, 5 goes in the top one time. 1 times 2 times 9 is 18 over 1. Why, that's 18. Plus, let's say plus, 5 times 1 is 5. 18 plus 5, yeah, got it. That's 23. So x does equal 9 over 5. Okay, go over this stuff. Good luck with it.